I heard VU was looking into it, I thought I would do it. So real quick, VU is constantly looking at new technical options and looking at stuff like that. And I've heard gRPC passed around a lot. I think it's a really interesting kind of technology. I ended up doing a thing on a hackathon over gRPC, and I really liked it. And since I heard VU was looking into it, I thought I would do a Propeller Heads and Pizza over it. Propeller Heads and bring your own pizza. But anyways, start out gRPC. What's that about? So, quick thing in this meeting, we'll go over me, who I am, why or why not you should listen to me, where the need of gRPC came from, what it is, how it works, what it's good for, what it's not good for, and a really short demo. So a little bit about me. I'm a software developer on Sales Channel, specifically Table Flip. I graduated from Mizzou in 2018, and I've been working at VU ever since. Before going to school, I worked in the IT industry for about 5 years, government agencies, a lot of government work. I also worked as a researcher, so I managed the researchers' IT network. So I have somewhat a background in IT. I would actually say I have more IT background than software development. But anyways, so that's a little bit about me. I change my hair a lot, if you can't tell. Sometimes I have beards, sometimes I don't have beards. Sometimes I don't grow out my long blonde locks. And if you ever see me in Slack, I typically have some variation of the bear. So anyways, enough about me. gRPC falls in like an interesting place because as developers, we typically focus on code. We typically focus on improving the code. System administrators typically focus on being system administrators, making sure security is up to date, the servers are up, everything's working. Network admins focus on making sure the network works. So routing protocols and stuff like gRPC kind of falls through the cracks, I think. I just don't think anyone really thinks about it. And everyone's focused on, creating efficiencies in other areas. But so gRPC kind of falls back. There's this idea of instead of building these monolith services that we used to do, that we break each part of the service into like a microservice. So these microservices handle specifically a specific task, and then you kind of put them together as in like you would functions or methods inside of a class. So good things about microservices is you can deploy them separately. Changes there, quick to, easy to debug, quicker to find out where the problem is within those microservices and everything like that. And while a lot of that can't be argued, one bad thing about microservices is it pushes all of the computation time down into this transit. So instead of easily passing from the UI to the business logic to the data access, we're now going from the UI over a transit or over a network to the next microservice, and then it's hopping back. So we're sacrificing the speed and efficiency of our data transit to the powers that be in the network land. If these services are all on the same server, that's something as easy as just a local port number or calling a different port. If these services are running on different boxes, which I think most of them are, that means we're now going over fiber or copper lines in network interfaces. So not so good. So to find out where gRPC is, we have to go deeper. So when we go over a line, that brings us to technologies we typically see now. On Table Flip, we typically handle stuff that either falls under SOAP, which means we're using XML. We're doing this over HTTP, HTTPS. There's the REST architect style, which everything is stateless. You typically see that with JSON over HTTP or HTTPS. And then in addition to that, we see stuff like WCF, which is Microsoft specific And you can use REST or SOAP over that, but typically, or you can use REST over WCF. It's kind of like its own different thing. And WCF seems pretty good in theory. Like, plug it in, you're calling stuff as a method. You can run it either on a server or locally. But even Microsoft is moving away from WCF. And what they're moving to is they're moving to gRPC. So what is gRPC? It was developed at Google. So there's kind of a joke that the G actually stands for Google, which makes sense. But Google kind of ran with this, and they're trying to abstract themselves from it. So every new release of gRPC, the G actually stands for something else. In version 1.1, the G stood for good. In version 1.21, it stood for Gandalf. In the current version 1.8, it actually stands for galactic. So galactic remote procedure calls. It's a high performance, general purpose RPC framework, remote protocol framework. And RPCs don't really have the best history. Some people may remember Corbra or Java's RMI. They've kind of fallen out of favor. I've never actually seen them in the workplace, particularly here at VU. I don't know if other channels use them or anything like that. gRPC is part of the Cloud Native Computing Foundation. This is the same foundation that runs, quotes, stuff like Kubernetes, Prometheus, Envoy, Core DNS, and many others. And it's based on HTTP2. Relatively new, it came out in 2015. It has many advantages over the HTTP 1.1 that we currently use. Stuff like request multiplexing, header compressions, binary protocols, which all come in handy with gRPC. And last but not least, it's this open source version of Stubby RPC that Google's been using for a long time. So it's built upon fixing the issues that Google found with its own Stubby project. And you may be asking, what's the difference between this and, say, like the APIs we currently use? So here's some difference for them. The contracts, if you're dealing with JSON APIs, you don't really need a contract. You can see what they're giving back, and you just kind of choose what you want. Where gRPC, it requires protobufs, which we'll go into. HTTP versus HTTP2, JSON protobufs. Here's some quick changes. We'll go over some of the stuff more in detail. But yeah, so gRPC came from the need of working with microservices. To be honest, microservices kind of suck. They're really hard to work with. The contracts are constantly changing. You change a version of one microservice and you just broke all those dependencies. You break a contract, you just drop this whole system. You can, of course, roll it back, but yeah, I mean, that's a problem. On top of that, now based on your network latency, because there's exponentially more network hops than were originally. So Google found the difficulties in working with this, so they created Stubby. So Stubby came out in RPC. It can handle tens of billions of requests. And they found out that, unfortunately, much like most projects, that when they built it, they kept expanding it. So by the time HTTP2 came out, Stubby was just this behemoth that didn't, it solved its problem, but then they tried to force it. So when HTTP2 came out, they decided to just rewrite the whole thing, bottom up, and to make it utilize new features and to be open source, much like the success they've had from stuff like Kubernetes. So nowadays, gRPC supports over 11 different programming languages to include Go, Ruby, C#, C, PHP. It's used at these massive companies such as Netflix, Square, Cisco, and CoreOS. So that's kind of where it was. This is how it works. So you create these stubs on your clients. And these clients create these open streams with the gRPC server running. Because everything's built on these protobufs, the actual language doesn't matter a whole lot. So the server runs this gRPC server to handle clients. The client application is able to call methods directly on the server-side application. This protocol buffer is what they call an interface definition language, and it's to enable the communication between these two different services. It describes both the service interface and the structure of the payload. To increase efficiency in all of this, the messages are serialized on both sides and encoded. This connection from the client to the server is actually one connection, and they utilize HTTP2 streams, and every new RPC call is a brand new stream. And real quick, that gRPC actually allows client streaming, server-side streaming, and bidirectional streaming. And we'll get into that later, but it's really cool. So the benefits of using gRPC. There's a lot of benefits to this, but I mostly wanted to go into the performance you can get from it, the streaming that we just talked about, and then the benefits of standards. So performance, we talked about this earlier. gRPC uses protobufs. gRPC is fast, like really fast. And these protobufs do a serialization, so you're not sending just strings of JSON over the line, you're sending these serialized requests. There's a lot of performance benefits already from using HTTP1, and I don't know if this opens here. I actually hope this. Okay, yeah, we're good. So you can see here, loading this image costs 4.5 seconds. We're loading an HTTP2 took half that speed. I actually did this at the hackathon, and the HTTP1. So I'm actually really happy to see that this is actually supporting me this time. That's great. Okay, anyways. So we're already working on a faster thing, and then gRPC is improving this. And then we also have binary framing compression. So these requests that were a lot quicker, so much quicker that on a study done where they pulled out just these massive data sets of geolocations in geo settings, that they found out while in small payloads, the difference wasn't that big, that in large payloads, you're looking at stuff relatively half the time to transport this information back and forth. This is because of the protobuf. So I don't know if anyone's watched the show The Expanse, but in The Expanse, the protomolecule is this molecule that goes around to different organisms and kind of claims them as their own. So the organism loses its own thing, but it gains this tremendous speed and power. And that's exactly what happens with these protobufs. So these protobufs are the contracts that gRPC uses. And here you can see an example of them serializing a message. And this is what makes it easier to mix and match languages. But generally, we can see here that we have a message, a person. And on here, the names and strings and phone types. And then on top of that, this person can hold multiple phone number of the phones. And then this address book holds multiple of the people. And this is used using this protobuf language. So stuff like repeated means that kind of like a list, or there's more than one. So this is how you would serialize just a model if you wanted to use it for transportation. And here we have protobuf. I kind of cut off the very bottom of this thing by accident. But we can see how it relates to other different formats of transmitting this stuff over the line. So we have XML, JSON, CSV, regex, protocol buffers, and the protocol buffer has the most capabilities out of all of them. But hold your butts, Beltalotas, because we ain't done yet. Another benefit is streaming, and this thing's your channel. gRPC comes hard with the streaming. Using this HTTP2, it's able to do any combination of streaming. And I didn't know what all these streaming things meant, so I wanted to go over them real quick. Unary streaming is your typical client sends a request, the server receives that request and responds a response back. So typically, like you typically see the normal JSON REST endpoint calls. Server streaming is when a client sends a single request to the server, but receives the sequences of messages back. And gRPC guarantees the message ordering within an individual call. So this could be really handy if you're pulling 2,000 database entries out of a database, but you don't want to overload the database, so you have it return 100 entries at a time. So this is just breaking down the task, and then it's streaming it back to the client. And as just mentioned, gRPC guarantees message ordering within this, so it's almost like you're querying for all 2,000 at the same time. Client-to-server streaming is exactly what server streaming is, but backwards. So the client can send out multiple messages, and gRPC will guarantee the ordering of this correctly. And then finally, we have bidirectional streaming. And this is when both are sending each other just the sequences of messaging and operations. So it's kind of like a WebEx call when everyone's talking at the same time and no one really knows what they're saying, but gRPC will keep track of that, so it's much easier to communicate. And finally, I have standards. So this may be a pro to some people. I think it's really cool. Other people might not think it's so much, but gRPC has to follow a standard. gRPC enforces contracts. So kind of like we've been experimenting with Hub lately, and we have the you have to follow Swagger Hub generates. You can't change that because then the people calling you will won't be able to retrieve what you're doing. And that's just what gRPC does. But the good thing is, because gRPC is open source and has a lot of research in it, that these specifications are well known and easy to follow. And do research on what exactly you're looking for. Let me see. I swore one of these was something I actually wanted to show, but apparently that's a virus, so I'm not going to open that. So with these languages, they have specifically how you should set up stuff, the exact serialization you should follow, and how to deserialize these things. So while this may be a negative to some people because it's it's not very loose, like there's no different interpretations, I think it's a good thing. Particularly if we start focusing on centralizing our documentation and following documentation, which I think stuff like Swagger Hub really helps out with. And because there's standards on using gRPC, that carries over to stuff like authentication, load balancing, logging, and monitoring. All of this is standardized and a lot easier to implement. Also gives the capability that if you switch to another service using that contract, you know exactly what's happening. So it doesn't sound all great. And there are lots of good things, but not everything is good. gRPC now requires that your API is defined in another language. So, hey, you know how to write an API in C# and use classes. That's great. We're not doing that anymore. We're using protocol buffer or protobuffers. So your open specs, your JavaScript's consuming APIs, that's just something else. This is just something else to learn. We spoke on this the last time, but this requires documentation. It requires the documentation to be kept up, which I think is really hard. It's just another task for you to do. You can't just, like you do a JSON endpoint, you can't just hit it and see what it returns and play around with it. If you try to hit a gRPC service, which I think in the demo, it will just tell you this is a gRPC service. You can't get any information from it other than that. It's not easy to do deep because so much of this is abstracted out. You can't just step stuff through like you could your typical REST JSON endpoint. And then finally, it's not mature. So gRPC is really new. HTTP 2 came out in 2015. gRPC came out around late 2015, early 2016. And that was for just a few languages. And now it's growing and it's being adopted by the industry, but there's no amount of tools like we currently have. There's a lot of technical aid for stuff like developing SOAP and PDF services. And a lot of that just doesn't exist yet for that. And finally, it's made by Google. And Google kind of has a history of getting rid of technologies for any Google inbox users that may be out there. And I have a demo, and I'm sure if I can actually get this demo to work. I take that back. So I have the demo working. I have a JavaScript thing of using gRPC. I went and converted to C#, but I actually just didn't get around to it. We've had a lot of fires today. So anyways, so here on this chat server, we have this Protobuf. You can see here that we're sending a message. We serialize user to 1, text to 2, and we have this service. We have stuff that joins, sends, and proto 3, which is the current syntax. So using this, we know exactly, 1, what's going to happen about it, and then 2, we have the exact message that both sides can be able to use it, no matter Go, Golang, C#, C, what have you. On the server, we bring in this gRPC and this proto loader, Delta Loda, and we have this server runs on 501. This is just some JavaScript just to define how to play around with the Protobuf. But basically, this is it. So we have users. We notify chat when they come on. We're able to write to each other. And this is it. And we're creating a gRPC channel right here in secure. So one good thing is you can add authorization, you can add logins, you can add stuff like Okta and third-party authorization, OAuth. And then we have the server starting. Likewise, we have client, same thing. It just reads this in. But generally, you just call this proto and it knows exactly what you want. So let me start this up real quick. Sure. What do I have in my documents? Just gRPC. Okay. So we have this server. Let me see if I can pull up the error on that. No. Okay. Oh, darn. So I can't actually. But let's pull up. Let's make a couple clients. So now, and as simple as 50 lines on the client and 40 lines on the server with decent formatting, we have a chat room using So the stuff sending back and forth is serialized. It's quick, it's efficient, relatively easy to pick up. You just make sure everything you're loading from the proto loader and the Protobuf. And yeah, that's it. This comes really easy with Visual Studio 2019. There's actually an option, if I pull up Visual Studio right now, if you create projects, there's templates for use with the gRPC that come natural with this. So you don't even really have to like go out of your way to create a gRPC service if you wanted to play around with it. And as I kind of mentioned earlier, there's lots of documentation. Microsoft's mentioned that they're kind of giving up on WCF and pursuing gRPC, which I think kind of like leads the way with how the company wants to go, much like how they're following core now. And out there that will convert your WCF services into gRPC services for you. So you don't even go through the hassle of programming anything. You're able to just download the service and have it change it for you. And that concludes my presentation. If you have any questions,